Do you know that statistics can be applied in real life? Just like when you're drinking coffee. Nowadays, a lot of people are being obsessed with coffee. But do we know that a cup of coffee can affect the duration of our sleep? In this video, we will be having two sets of continuous data. Later in this video, we will understand the correlation between the two sets of data, if there is a positive correlation, negative correlation, or no correlation. For us to understand if a cup of coffee might affect our sleep at night, we will be using the Pearson product moment correlation.
Pearson product moment correlation. This formula was named after Carl Pearson. This formula does not only show how greatly two datasets are correlated, but also if the datasets are not correlated. These are the general ranges for interpreting correlation coefficient.
Here's our data from person A to F.
To better understand, let's put it in a table.
These are the datas that we have from person A to F. X will be their caffeine intake, while Y is the number of their sleep at night. This study seeks to explore the relationship between coffee consumption and sleep duration by examining how the number of cups of coffee consumed during the day may affect the number of hours a person sleeps at night. Specifically, it aims to determine whether higher coffee intake is associated with reduced sleep duration, and to what extent this relationship is evident among individuals with varying daily caffeine consumption habits. This is the formula of Pearson product moment correlation, but let's simplify. R sub x and y is equals to the summation of x sub 1 minus the mean of x times y sub 1 minus the mean of y divided by the square root of the summation of x sub 1 minus the mean of x squared times y sub 1 minus the mean of y squared.
Now let's start the calculation. The first thing we need to do is to look for the mean of x and the mean of y. In order to get the mean, we have to get the average. This is our x data, while this is our y data. So we have to get the average of x data and the y data. So to get that, we have to add all the datas together. We have 21 in total and divide it by 6, which is the total number of our datas, which we get 3.5 as our mean of x. But in Excel, you can simply type in equals average and then select this data up to this data, and then equals, and it will automatically give you the mean of x. Same with the mean of y. We have to sum it all up and then divide it by 6, which we get 6.5 as our mean. Now let's add another table. So it says here we have to look for the x sub 1 minus mean of x. We already got the mean of x, which is 3.5, so this is our x sub 1. 1 minus 3.5 is equals to negative 2.5. 2 minus 3.5 is equals to negative 1.5. 3 minus 3.5 is equals to negative 0.5, and so on. It also says here we have to look for the y sub 1 minus mean of y. We already have the mean of y, which is 6.5. Now let's subtract. 8 minus 6.5 is equals to 1.5. 7.5 minus 6.5 is equals to 1. 7 minus 6.5 is equals to 0.5, and so on. Now on the upper part, we are almost done, but we're missing something. We have to multiply the x sub 1 minus mean of x and y sub 1 minus mean of y. So to get that, we need to add another table. So negative 2.5 times 1.5 is equals to negative 3.75. Negative 1.5 times 1 is negative 1.5, and so on. And right here, we have to sum it all up because again, we're looking for the summation of x sub 1 minus mean of x times y sub 1 minus mean of y. So let's just sum it all up and we'll get negative 11. In our denominator, we have to look for the summation of x sub 1 minus mean of x squared times y sub 1 minus mean of y squared. We already got the x sub 1 minus mean of x. Now we just have to multiply it by itself. So negative 2.5 times negative 2.5 is 6.25. negative 1.5 squared is 2.25, negative 0.5 squared, 0.25, and follows. Now we have to get its summation. Its summation or its total is 17.5. Now same goes with our y sub 1 minus the mean of y squared. So we already have the y sub 1 minus mean of y. We just have to multiply it by itself. 1.5 squared, 2.25. 1 squared, that's 1. 0.5 times 0.5, that's 0.25, and so on. Sum it all up, we got 7. Now, we can substitute all of the answers that we have to get the answer of r sub x and y. But in Excel, we can simply input this formula. Equals Pearson, open parenthesis, this data up to this data, and then this data up to this data. Close parenthesis. So our answer is negative 0.99.
So our correlation coefficient is negative 0.99, which indicates strong negative correlation between cups of coffee intake per day versus sleep duration at night. So today we have learned that we can apply statistics in our daily life. So whenever you have two sets of continuous data to quantify, you can simply use the Pearson product moment correlation, which is an easy way to compute and interpret data, which makes it a standard tool in statistics in many fields, such as psychology, economics, medicine, and education. Hope you guys learned today, and goodbye.